In this video, we will go over the 2008 AP Physics C Mechanics free response. Here's the first question. A skier of mass m is skiing down a frictionless hill that makes an angle theta with the horizontal, as shown in the diagram. The skier starts from rest at time t equals to 0 and is subject to a velocity-dependent drag force due to air resistance of the form F is equal to negative bv, where v is the velocity of the skier and b is a positive constant. Express all algebraic answers in terms of m, b, theta, and fundamental constants. So the first part asks to draw a free body diagram of all the forces acting on the skier. Of course, there will be the force of gravity, which will always be pointing downwards towards the surface of the Earth. There will also be a normal force, which will be perpendicular to the surface of the incline. We will use n to represent normal force. Finally, the question states that there is a drag force. The direction of v, the velocity of the skier, is down the incline. Since f is equal to negative bv, it will point in the direction directly opposite to the direction of motion. Therefore, we will have a force F pointing up the incline. Since it says at the top that it is frictionless, there will be no friction force. The second part of the question asks to write a differential equation that can be used to solve for the velocity of the skier as a function of time. Well, we know, according to Newton's second law of motion, that F is equal to ma. To solve this problem, we need to find all the forces, or their components, that act in the same axis of A. Let's look at the free body diagram again. There's F, which acts in the direction directly opposite to A. N is completely perpendicular to the direction of A, so it has no effect on the acceleration down the incline. If we look at the components of mg, we can see that mg sine theta is a force acting in the direction of A. Therefore, the net forces acting along A's axis is mg sine theta minus F, which is equal to ma. Remember, we are subtracting F because it is acting against A. A is the derivative of velocity over time. So we can replace A in the equation with dv over dt. And that's our final answer. The third part of the question asks us to determine an expression for the terminal velocity of the skier. Terminal velocity is the max velocity that the skier can reach. At that point, velocity is at its maximum, and so it can no longer increase. Therefore, zero change in velocity means that acceleration is equal to 0. Since there is no change in acceleration, the net force is equal to 0. So, if we use the equation we found in part B, which was mg sine theta minus F is equal to ma, we can solve this problem. Acceleration is equal to 0, so we get mg sine theta minus F is equal to 0. It was stated in the problem that F is equal to bv, so we can plug that into the function, getting mg sine theta minus bv is equal to 0, where v is equal to the terminal velocity in this case. We can solve for the terminal velocity to get mg sine theta divided by b. Part D asks us to solve the differential equation we had found in Part B. Here's the equation we had found. By rearranging the terms, we can get that the integral of dt over m is equal to the integral of dv over mg sine theta minus bv. We can then use u substitution and take mg sine theta minus bv as equal to u. Therefore, du would be equal to negative b dv. Solving the left side of the equation, we get t over m plus c, and c is a constant. On the right, we can substitute dv with negative du over b, and mg sine theta minus b, v can be substituted with u. We can factor out negative 1 over b, and multiply negative b to both sides of the equation to get negative bt over m plus c is equal to the natural log of u plus another constant. We can eliminate c1 on the right side by subtracting c1 on both sides of the equation. c minus c1 is just equal to another constant, so we can just write negative bt over m plus c is equal to ln of u. We can then write e to the negative bt over m plus c is equal to e to the natural log of u. If we rearrange the equation, we get e to the negative bt over m multiplied with e to the c, which is all equal to u, since e to the natural log of a number is just the number itself. E to the constant is just a constant. And recall that u is equal to mg sine theta minus bv, so we can now resubstitute that into the equation. To find what c is, use the initial condition t is equal to 0, when t is equal to 0, v is equal to 0. Plug these values into the equation and solve for c, which we find to be mg sine theta. Plug in this value of c back into the original equation and solve for v to find the final answer. Finally, part E asks us to sketch a graph of the acceleration as a function of time t, and we can take downhill as positive. Well, we know the equation of v in terms of t. We can multiply out the term mg sine theta over b, then take the derivative with respect to t to find a. You can simplify the equation and get dv over dt is equal to g sine theta times e to the negative bt over m. To find the initial condition, we can plug in t is equal to 0. When we do this, we get that a is equal to g sine theta times e to the 0. Since e to the 0 is just equal to 1, the initial condition of a was g sine theta. Since the graph is a negative exponential graph, it'll be concave up. Remember that the acceleration gradually reaches 0 until the skier reaches terminal velocity. So this is how the graph should look: concave up and gradually approaching 0.